Namaskar my dear friends. Let us talk about microcontroller schematic. So what we are doing is we are actually designing system design with microcontroller based circuit. This is session 4. So as you can see, we have started with the several block diagram around the microcontroller and we are finishing up one by one. So we have already finished the green background ones. Now why don't we do one thing? We will start with audio buzzer connection. Okay, so as you will be seeing, we may need to like have some alarm buzzer or something like that for our system. So let us say we need to have some beep sound, and for that we can utilize one audio buzzer, let's say magnetic transducer or something like that. So how we are going to put this circuit in OrCAD, that we will see, and at the same time we will also see how we can generate let us say 6 PWM, like 3 pairs of complementary PWM for motor driver. Okay, so as you can see, you have like 3-phase motor driver, and there you will be needing like 6 half bridge MOSFETs to drive. So for that we will be trying to utilize that. So as you can see, let me give you an example. So let us say this is the way we have motor phase ABCs, right? And these are the Q1, Q2, Q3, Q4, Q5, Q6. So they actually run by PWM. So as you can see, one PWM is here, 2, 3, 4, 5, 6. So total 6 PWMs will be required to run this particular full bridge circuit. Okay, so we'll do this particular design. First of all, we'll start with audio buzzer, and then we'll also assign PWM for different IOs. Okay, so let's open circuit. So as you can see, I have removed most of the IOs so that I can get enough space for putting my PWM signals. Now very first thing that we have to do is we have to design, let us go to page number 2. We have to design audio buzzer circuit, right? So for that audio buzzer circuit we may need to place the parts. So first I'll just place buzzer. So I have a buzzer symbol, so I can use that. I need to add library here actually, so go to library, and there is no library available, that's the reason it is not coming. So add files, and you may see that you have to add the library. So as I have library now available, so I'll go to the part and let us search for buzzer. So we have buzzer here, right? Now we need to have one freewheeling diode as well, so let us put one diode. I'm going to put a diode, and we need one transistor. Okay, if you want you can utilize MOSFET as well, but right now I'll just give you an example with transistor. So let me just put a transistor. To drive this transistor we may need the PWM signal, that's the thing that we are going to do. However, before that we can have a voltage division so that we can supply base to emitter, right? So base emitter voltage source we have to give. So for that I'll just use a resistor, let's say 0603 package. So this is how I am going to use, and this is how I am going to use. Okay, now almost our circuit is complete. We'll just connect them. Now I need ground and power symbols. I'll take it from first page directly since it is already available, so I don't want to go to place and this thing. So I'll just take power and ground from here, so copy and paste it. Okay, all right, we have almost all the symbols ready. Now what we'll do is we'll just quickly wire it up. So let us wire this. Let me make it little big by moving this one little left side and that little right side. Yes, we have ample space now. Okay, so we are going to connect my ground this as well. Let us connect this way. then this is going to get connected here, and this will be my voltage division for supplying to the base, and this is the place where we have to give the PWM, right? So I am going to write down here buzzer. So buzzer will be the net name so that this can be get connected. I'll just correct the spelling, buzzer. Now why don't you do one thing, one more resistor, I'll just keep it here, so that like sometimes what happens is there is a requirement of resistor for other kind of buzzers, like this is magnetic buzzer, so we'll be putting some other kind of buzzer, so I can put one resistor provision also in the PCB, so that we don't have to change it later. So I'll just keep it not used or do not mount. So this is how I'll be designing the circuit. So alright, this is good. Now let us put this buzzer point in our one of the IO where it is having the capability of generating PWM. Now how to decide which pin is able to generate my PWM? That's the thing that we are going to decide now, because we have seen ample amount of like connecting LEDs, push button, dip switches and all those things. Now we had not seen the pin functionalities and pin capabilities, how they are capable of doing different tasks, right? So we'll start with one by one. So what we can do is we can open the data sheet of this particular microcontroller. So this is the particular microcontroller MSPM0L1105 and 06. So what we are going to do is we will see the pin configuration or pin functionality where it is available, right? So I have here pin diagram and pin attributes. So there it is, pin attributes. Go to this pin attributes, you will see a lot of things that is already there, right? So we have pin number, let's say 1, and pin name is PA1, PA0, and these are the functionalities that is there, like it can have timer functionality, it can have I2C, it can have UART, it can have SPI, it can have BSL I2C SDA. So a lot of functionalities are there, right? And you can see which pin device is having what pin numbers actually, like pin number 1, pin number 4, pin number 4, like that. Okay, so our aim is to go ahead with 20 pin VSSOP, and this will be little confusing to decide your timers, which one to take, which one not to take. Okay, so they have one more table down just below this. We have signal description. Okay, so this signal description actually keeps a collection of all the ADC pin together. Similar to that, all other functionalities, let us say I have GPIOs, then let's say we have I2C pin, power pin, and we have SPI pin. Similar to that, we have timer pin as well. Okay, so what we'll do is we'll try to see which timer pin we can utilize for our buzzer purpose. So we have timer 0, timer G0, C0, and as you can see, this is the VSSOP 20 pin row or 20 pin column. So in that we will try to see pin number 12 and 18, then pin number 10 and 19, like that we have at one place. Okay, so what we will do is we'll try to use timer G2C0 and timer G2C1. You can see there is no pin available here. So since it is a single PWM we want to have, so we will use this one. Pairwise we will try to use as complementary PWM. Okay, so that will be a good idea. Understood? So timer G2C1, I am going to use one of the pin as general purpose PWM signal. So pin number 17 I can use, or 9. So pin number 9 or 17 I can use. If it is available, you can put it PWM for buzzer purpose, or 17 also you can utilize. That's the important thing. Okay, so what we can do is just press W, write a net name and put your buzzer. Okay, so my buzzer circuit is complete now. Okay, this is so simple. We have the buzzer circuit and we have assigned a pin for getting a PWM so that it can drive that. And one more thing you have to understand is, if you are using this buzzer, you have to make sure what is the voltage rating for this particular buzzer. The buzzer which I have identified was actually working with 3.3 volt. Okay, if you use 951 AP, then it will be working with 5 volt. So you have to make sure you have attached 5 volt here for 5 volt buzzer. Okay, now let us do the PWM for this particular motor drive. So what we will do is we will try to identify. So let us say I have taken this PWM in complementary mode and I have assigned PWM 0, P0N, that is complementary first pair, then complementary second pair and complementary third pair. Okay, and I have also thought of, like, let us say pin number 12 and 18, I will use 12, then 19, then 1, then 2, then like 19, 17 is there here, that is not a problem. Here 13 and 14. So let us do that and assign those pins as PWM for our motor driver application. Okay, so let's start. Come to page number 1. What we are going to do is we are going to assign PWM numbers, right? So pin number PWM 0, P and 0N. So what we will do is PWM 0, P and 0N, we will start with pin number 12. Okay, so I am going to put pin number 12 as PWM 0P. Then pin number 19 will be my PWM 0N. So pin number 19 will be my PWM 0N. Then we have PWM 1P. So 1P will be pin number 1. Okay, so I'll put it as 1P. If you want, you can like use PWM 1, 2, 3, 4, 5, 6. So that will be a good idea. However, I am writing like in positive and negative so that I can understand that this is my complementary pair together. Okay, so it's up to the designer, like how do they want to write down the pin configuration and pin naming, right? So we have two pairs done, like PWM 0N 0P and 1N 1P. Now we need pin number PWM 2P and 2N. So what we will do is we will just put this as 2P and 2N. So let us say this will be my 2P and this will be my 2N. Got it? So our this particular microcontroller is now capable of going to give you 6 PWM outputs to run the this particular motor driver bridge circuit. Okay, now in my opinion, if you are going to design for this particular motor phase drive, then what you have to do is, instead of utilizing this particular microcontroller, which is 20 pin microcontroller, always go ahead with 32 pin VQFN microcontroller. Okay, so you can take this as a note. To drive for this motor application, you can go ahead with MSP M0L1306. Now one more thing we will add before closing this particular session is, all these 6 PWMs will send it to a connector so that that can be utilized for driving the motors, right? So what we will do is we will connect here one connector. So let me just connect it. Connector 6 pin. Alright, so 6 pin connector is there with us. Now we will put a resistor and capacitor also, like RC circuit, so that we can have a proper filtering before sending it to the connector. Okay, so we can have RC circuit, or otherwise in the motor driver circuit you can have RC circuit there as well. Okay, so I will just show it to you here how to put it. That will be a nice idea. So what I will do is I will take one of the resistor from here and put it here, and let us say I am going to take this resistor as 100 ohm. Okay, and then make 6 resistors. Okay, now connect them quickly. So if you connect them, it is done. Okay, now we'll put RC circuit also. So for that I need to have capacitor. So let us say put capacitor 0603. I will just put it. So 6 capacitor I have put it. What I will do is I will quickly draw the circuit. So drawing the circuit is an art, so you have to understand like how to draw very properly nice circuit. Okay, it's all about like your patience and your caliber, like how much time you want to give for drawing the circuit. So it must like catch the eyes of the engineers. Okay, this is a very beautiful circuit that we have done. Now what we can do is we can write down the net name with our complementary PWM. So what we are going to do is we are going to write down PWM 0P0N, like that we will put it. Okay, so let me just copy and paste the same net names to each one of them, and later I will change the names. So this is my 0N, this is my 1P, this is going to be my 1N, this is going to be my 2P and 2N. Alright, our PWM circuit is ready. Now what we will do is we will change the connector properties as well, so that it will be a good idea for you to understand like which connector we are going to use. So let me just give you an example of 2.5 mm pitch. So 2.5 mm pitch from Worth Electronics I have taken. If you want, you can double click this and put all other values, like let's say manufacturer, manufacturer part number, description, all these things. So you have to add new properties and add them, because the library component has not those properties. So what you can do to make it little quicker is, let us say this capacitor I will select and this connector I will select, both of them together, and then double click it. So whatever the properties that is defined for capacitor, okay, the like manufacturer, manufacturer part number, that will be available for this as well. Okay, so that's the meaning of this. Now we will quickly put that. So let us say I am going to put manufacturer part number as the value that I took. Then the manufacturer is Worth Electronics. Then we have description as this. So our bill of material will also be now ready with this part numbers. Okay, so this is how we good. Now what we can do is we can double click it and see if everything is fine. Let us generate the PDF for this. So file, you can print it. Let us print and write down that my schematic microcontroller with buzzer and PWM. Okay, so now we are ready with our schematic, and let us open and see how does it look like. Alright, so it looks like this. We have 6 PWMs plus one additional PWM that will be for buzzer purpose. Okay, and you can see all these PWMs have been connected here with RC filter, and this is going to the connector that can be connected to the daughter board, which is going to have my IPM driver or maybe anything. Okay, so if there is intelligent power module which is driving the motor or something like that, there you can drive send this particular 6 PWMs. Okay, so alright guys, thank you. Hope you have understood all the concepts that I have explained here, and this is the way you try practicing it to master your microcontroller circuit design for your understanding. Thank you.